Hi, let's have a look at the answers to question 8, all about map H in your Theme 14 booklet. The first question asks you to highlight the igneous rocks on the map. So let's do that. So we've got basalt and we've got the dolerite shown there. Basalt in yellow, dolerite in red. Notice though we've got photos showing some andesite. We need to think about where that's going to be. We'll come back to that in a moment. Now I did ask which of these rocks is represented by specimen Z. And the answer is it's dolerite. This is an igneous rock that's mafic in composition, so it's dark in colour, and it's got medium-sized crystals because they're about 2 millimeters across. I then asked you to draw the axis of the fold, so let's get rid of that, and put the fold axis in there. This time we have an antiform, as the beds are dipping away from each other, so the oldest bed there will be in the middle. Now photograph H1 shows a feature in the basalt. That feature is pahoehoe. This is where we get a thin crust on top of the basaltic lava, sort of folding over, wrapping itself around on itself as the flow occurs. It tells us we have a lava flow. Photograph H2 then shows an outcrop of rocks at location H2. The andesite body there is shown to be north-south. We can also see that it's long and thin, so it's sheet-like, and it cuts across the layers in the sedimentary rocks. So clearly it must be a dike. And also, we can see at the top of the andesite there, the dolerite is cutting across the top of that andesite. So if we're drawing that on the map, that andesite is going to be cut through by the dolerite. The dolerite must be younger than the andesite. But we can also see that the andesite cuts through the basalt. The basalt must have been there before the andesite. So this sort of begs the question about what these different igneous bodies represent. Clearly, the andesite must be a dike because it's, well, we'll come to the evidence in a moment. The basalt, on the other hand, is a lava flow. And the dolerite is a sill. Now, the evidence we have for this, for the andesite we've talked about already. It's sheet-like and it's discordant. It cuts across the layers in the sedimentary rock. The basalt, though, must be a lava flow. There's two reasons for that. It's only got a bake margin at the base of the basalt, and also we see that pahoehoe surface. That'll be on the top of the lava flow. Dolerite, then, is a sill, and we know that because we have two bake margins, top and bottom, and also the crystals are medium size. It's cooled a little bit slower. Okay. If we look at the table of rocks and the order that they form, the oldest one is limestone in the middle of the antiform. The basalt lava flow must have flowed out then on top of that limestone, but before the conglomerate was laid down on top of it. We then have the mudstone and the shale. Remember, rocks get younger in the direction of dip. The andesite then cuts through all those sedimentary rocks and the basalt. And finally, the dolerite is the youngest as that cuts through the andesite. This is all about applying the law of cross-cutting relationships, as well as superposition. Finally, those of you that had to go digging deeper, this is quite a complex idea, but the dip on the cross-section doesn't show a 35-degree dip because that angle of dip isn't along the line of cross section. There's a line, there's an angle between them, so therefore the dip will look like it's less than 35. It's an idea we call apparent dip, if you want to go and Google it. If you've got any other questions, please get in touch. I'll see you then.